Hi, my name is Arlene Olivero, and I'm a spatial ecologist with the Nature Conservancy's Center for Resilient Conservation Science. I worked on the freshwater resilience analysis, and today in this video segment, I'm going to show you how to use the Resilient River Explorer tool to learn more about the flow alteration component of the water score. Within the tool, you'll want to go to the Explore the Data section. This tab helps users better understand a watershed's freshwater resilience score. You can explore the metrics and source data sets used to assess each resilience component. Let's click on the component metric diagram to see where flow alteration fits in the overall model of resilience. You can scroll down here and see that flow alteration is part of the water score, and together, flow alteration combined with potential water availability form the water score. We can also see here in green boxes the metrics used to assess flow alteration, while in the red font, we can see the source data sets that are available for viewing in the tool. Let's click on flow alteration on the left here. You'll see the map changes from showing overall freshwater resilience to showing the flow alteration score. Rivers in blue watersheds have less alteration of their hydrology relative to rivers in brown watersheds. Flow alteration was assessed using the Hydrologic Alteration Index, or HAI, calculated for the lower 48 states in a study by Ryan McManamy and others that was published in 2022. The HAI compares stream flows to reference conditions at a set of gauges, and then uses predictive models to assign a degree of flow alteration to each stream reach in the coterminous US. In the freshwater resilience analysis, a length-weighted average of the HAI scores for perennial river reaches was calculated for every Huck 12 watershed. You can click on the question mark icon next to flow alteration to learn more about the HAI and how it was used to generate the flow alteration score. Now I want to zoom in and look at flow alteration of a particular river with you. We're going to explore the North Platte River in Wyoming. I'm going to go down to the map layers section and turn on a few layers for reference. Start with states, and I'll zoom in to Southeast Wyoming. Now I'll turn on a few other layers for context. I'll turn on rivers. You can see the North Platte here, and I'll turn on river dams. And we can see the North Platte is fragmented by several dams. We can also bring up the legend for flow alteration again and review the colors we see on the map here. I see a lot of brown far below and below average along the main stem of the Platte River. Now I'm going to turn on the additional metrics and source data buttons so we can take a closer look at the flow alteration data. With those buttons turned on, we can expand the flow alteration box and see additional options. Let's start by turning on the Hydrologic Alteration Index button. This is showing us the input or the raw HAI index scores for each reach catchment. You may remember I said that For our scoring for resilience, we summarized the data at a HUC 12 watershed level, but the input data actually came at a finer scale for every reach catchment, as you can see on this map. Looking at this input data, we can see in darker red the more altered catchments. I'll zoom in a little bit more here. And we can see all along the main stem plat that the reach catchments, almost all of them are in the darkest red category of the most altered class. We can turn off the hydrologic alteration index and look at the next data set here, flow regime. I'm going to turn off the rivers and we can turn on flow regime. We can see from the legend here that many of the streams and rivers in this area are temporary or intermittent streams, while some of them in the darker blue are perennial, indicating they have water throughout the year. Note that when the HAI flow line scores were summarized for each HUC 12 watershed, emphasis was given to perennial river lines, with rivers defined as having an upstream drainage area of greater than 100 square kilometers. Now let's turn off the flow regime and return to the base river line work and flow alteration score. For HUC 12 watersheds that didn't have any river flow lines intersecting them, the HAI for the headwater and creek flow lines was used instead. The next two metrics allow us to see the difference in the river versus the headwater HAI summaries. When we click on the river HAI score, you'll see the watersheds in gray are those where the headwater alteration score was used because there were no river reaches intersecting that HUC. Turning on the headwater alteration metric shows the flow alteration scores for each HUC based only on the flow lines with less than 100 square kilometer drainage area. You can see how using only the headwater and creeks can dramatically change the flow alteration score. You can also see where the headwater score was used versus where the river score was used by reviewing these layers. So again, this is the alteration score for the headwaters. This is the alteration score for the rivers. And then together, they come together into the flow alteration overall score, which uses the river score if it's available. And for HUCs where there are no rivers, it uses the headwater score. From the published HAI study, we know that dam storage, water withdrawals, and land use are important variables in the model used to predict the hydrologic alteration index scores. But unfortunately, maps, the predictor variable by importance, is unavailable. However, with my knowledge of this area, I know that the North Platte is used for agricultural water withdrawals. In addition to the dams and dam storage and communities on the North Platte, agricultural water withdrawals are likely a driver of flow alteration in the system. We can review the land used in this watershed by turning on the land cover. So let's turn on let's turn off the resilience results and review the land cover. And go down here, turn this on. And again, I'll zoom in a little bit more here. Reviewing the land cover, we can see there are some large row crop areas along the river in brown. There are also some areas of red, showing several urbanized areas along the river, both of which disrupt the timing and the quantity of water flow in the river here. So likely this row crop agriculture and these urban areas are affecting the timing and the quantity of the water flows in this river. For more details on how the individual metrics were calculated, scored, and integrated into the overall flow alteration score and resilience score, please refer to the Freshwater Resilience Report. If you click on More Info up here, you'll get this menu, which will bring you to the link for the project report where you can download it, or other documentation we have available here, other webinars. You can also provide feedback here or download the data if you wish to work in GIS with the data. This concludes my tutorial on how to explore the flow alteration component of freshwater resilience. Thank you.